So in this video I'm just going to show you how we calculate with the binomial distribution and how we set the questions out. So I'm going to use a very straightforward question. So we've got Kirk and Les regularly play darts. The probability that Kirk wins any game is 0.3 and the outcome of each game is independent of any other. So the second you hear these phrases, probability of someone winning, i.e. a success, and that each game is independent, you should start thinking about binomial distribution. Find the probability that in 15 matches, Kirk wins exactly 5 games, fewer than 3 games, more than 2 but fewer than 6. So we can see there we've got our probabilities kind of mulling over in our heads. What we need to do really is, obviously we can see that this is going to be a binomial distribution because there's a success and a fail. And we've got obviously a set number of games that have been played, or picks if you want to look at it from the other video point of view. Now obviously a tree diagram would be virtually impossible here because you'd have 15 levels of branches and it would be a ridiculous amount of time to set up the tree diagram. But we know we've got this choose method that we talked about in the second video. So what I'm going to do first is I'm going to show you how to write this out as a binomial distribution. So obviously all our events we've denoted as x, and this little squiggle here means distributed as a binomial. So that means our events x are distributed as a binomial, and we have two numbers that we put inside brackets, something called n and something called p. Now n is our number of trials, what we call trials, which in this case is the number of games. Our p is the probability of success. So in this game, the probability of success is Kirk wins, and we know that's 0.3. Our number of trials is 15. So in shorthand form, we can say, okay, we've got a binomial distribution where the number of trials or games is 15, and our probability of success is 0.3. So in the first instance, we want to find the probability that Kirk wins exactly 5 games. Now if you imagine over the course of 15 games, those 5 games have been distributed anywhere across those 15 picks, obviously you'd have a significant number of outcomes, combinations. So in the first instance, we would look at, okay, we've got 15 picks and we can arrange 5 in any order. So that would be 15, choose 5, and that would give you the number of branches of your tree diagram that you would have to inspect. We also know that obviously he wins 5 of the games, so that would be the probability of success to the number of successes. So 5 of the branches would be 0.3, and then the remaining 10 branches of the 15 would be Kirk failing, and obviously as there's only 2 outcomes, obviously if one's 0.3 the other one has to be 0.7, they have to add up to 1. So that would be 0.7 to the power 10. Okay, I'm not going to calculate that out and work that out. You can do that on your calculators and see what you get as an outcome. What I'm interested in is how we set out the calculations in this video. Okay, so question 2. Fewer than 3 games. Now obviously fewer than 3, most people would say, well that's easy, that's 1 and 2. But you've got to remember, he may win no games. So this is the probability that Kirk wins 0, 1 or 2 games. Now this is slightly different because we've got ors coming in here. So let's look at the probability of him winning no games. Well, that would be from the 15 trials, how many ways can you have 0 wins? Obviously his probability of success, it would be 0 times 0.7 to the 15. So in other words, you're looking for the branch where there's no wins and there are 15 losses, and I think you'll find 15 choose 0 will only be 1. Or 1 game, so it would be the way of arranging 51 game out of 15. This time probably success is 0.3 to the 1 and 0.7 to the 14. So 1 win, 14 losses. And 2 games, well again, how many ways can you arrange 2 from 15? And it would be 0.3, so that would be the times there as well, to the 2 and 0.7 to the 13. Notice how the powers in each calculation always add up to 15. I'm just going to put that time sign in there. That was a slight error on my part. Then obviously what we do is work each individual probability out and then add them together, because we've got 0 or 1 or 2 wins. And then the final one, more than 2 but fewer than 6. So more than 2 but fewer than 6. So in other words, that would be him winning 3 or 4 or 5 games. So again, we know our probabilities and our trials. So winning 3 games would be how many ways on your branches where there would be 3 wins from the 15 goes, times 0.3 to the power 3 times 0.7 to the power 12. So that would be 3 wins. 4 wins in any order would be 15 choose 4 times 0.3 to the 4 times 0.7 to the 11. Again, notice my powers all add up to 15. Or he wins 5 games, 15 choose 5 times 0.3 to the 5 times 0.7 to the 10. And in these cases, in parts 2 and 3, it's just reading the question really carefully.